Hey everyone, welcome back to Ask Becca About Space. I am, as planned, still on the island, still enjoying myself up here. We've had some kind of Scandinavian summertime rain storms all week, but the weather last weekend was really good and the forecast is good for this weekend. So hopefully we'll be able to get outside and do some hiking on some of the many mountain peaks around here, which would be rad. And back in Oslo, things are still returning to normal. Everybody who wants to be at the Institute is able to do that under the new distancing guidelines for reintegrating back into the workplace. And there has been also some talk about relaxing travel guidelines between the other countries in the Nordic Alliance and Norway. So that means that probably pretty soon we will be able to have kind of untethered, or I guess like unrestricted, or at least easier travel between Denmark, Sweden, Iceland, and Finland. Okay. And Åland and Faroe and Greenland, I guess, but you know. So yeah, that's us. That's us in Norway. Things are good. The island is still free of the virus, but because Norway is a solidarity-based country, we continue to follow the restrictions that apply to the rest of the country as well. So today I am gonna talk about another world that's not the Earth, as per usual, since we talk about space. But my friend Lisa sent me a text and she said, "Tell me about enchiladas." So this is a little bit of a running joke between the two of us. What she means to say by enchiladas is one of Saturn's moons that is called Enceladus. And she calls it enchiladas because to her and to everyone, it sounds like enchiladas. So I'm going to talk a little bit about Saturn's moon, Enceladus. So Enceladus is one of Saturn's icy moons or cryomoons. On the surface of Enceladus, we have been able to observe with the now decommissioned Cassini mission pictures of not only heavy cratering on the surface of Enceladus, but evidence of glaciation and movement and flow. And on the South Pole in particular, Enceladus has these what we call tiger stripes. Basically, kind of from above, it looks like scratches on Enceladus's South Pole. And what those are they're likely canyons through which we have observed ice geysers, or basically ice volcanoes, shooting out of Enceladus's South Pole, which is awesome. Like, that's wild, because not only did the Cassini mission's onboard cosmic dust analyzer, which I used to do some analysis on back in 2012, the cosmic dust analyzer is on board Cassini, or was on board the now dead Cassini mission, crashed it into Saturn for some atmospheric data. So it's dead now. But while it was alive, we were able to analyze particles from the Saturnian system, and the cosmic dust analyzer would collect impacts from those dust particles and then understand at what angle did that dust particle come in, how fast was it traveling, and spectroscopically, what is it made out of? What kind of elements or molecules does that dust contain? And when Cassini was flying around Enceladus and flying kind of through these ice volcanic regions, or nearby astronomically, Cassini was detecting water and salt. And that meant that Enceladus was basically spewing out salt water, kind of like the salt water that we have in our own oceans, right? And that's a big deal, because in the search for extraterrestrial life, or life that is outside of Earth, some of the ingredients for life as we know it, so carbon-based organic life, is water and some sort of energy source. And Enceladus clearly has water because it is spraying it out into the space. But it also clearly has an energy source, right? Because this is an ice moon with not much of an atmosphere. And in order for water to be liquid, underneath those tiger stripes and then escape those tiger stripes as still liquid slash vapor as it diffuses into the lack of an atmosphere, so into space, um, that water has to be liquid somewhere, right? And how does water, ice, become water liquid? Well, it melts because there's some sort of heat source, right? So the idea is that it's possible that Enceladus has a subsurface ocean, probably based on what we're seeing, that is heated and maintained by some sort of geothermal heat source, right? These could be sub-oceanic vents, like the ones that we see on some of our ocean floor near the tectonic plates. But what is it that causes tectonic plates to move and create that friction and that heat? Well, there's something that's called tidal heating. And basically what that is as Enceladus orbits around Saturn, the gravitational pull of Saturn and the gravitational pull of Enceladus itself and the other moons of Saturn, because Saturn has dozens of moons, all of those gravitational forces kind of pulling on the moon at once create kind of a tug on the moon, Enceladus. And that tug creates friction, that friction generates heat, and that heat melts the ice, and that ice water is then expelled in energetic ice volcanoes at Enceladus' south pole. Okay, so that's really cool, but that's also not the only example of this that we have in our own solar system. If we go a little bit closer to the sun and we go back to Jupiter's orbit, Jupiter has a very similar moon called Europa. And Europa is also a cryomoon or an ice moon. And we also believe that Europa has a subsurface ocean because there is also evidence of flow, movement, scratches, as well as the cratering that we would expect on a moon that is not very well protected by any sort of atmosphere. And Jupiter itself and Jupiter's other moons have tremendously strong tidal heating forces as well as that, just like Saturn and Enceladus and the rest of Saturn's moons around it. But the thing about Europa is that it took a little bit of a different approach to determine that Europa also has these ice volcanoes. And these ice volcanoes were actually observed using methods that allow us to see just hydrogen and just oxygen, okay? And basically what was happening is we were seeing these kind of localized plumes of extra hydrogen, extra oxygen, so it's water. And then we were also seeing those molecules kind of distribute themselves around Europa. And so something was being expelled into the space just above Europa and then being distributed around the moon itself. So the difference between Enceladus and Europa right now is just in the way that we're dealing with them as human explorers, right? Enceladus is currently on the back burner because Cassini has been decommissioned. Actually, after on schedule, Cassini lived a lot longer than the mission report, and so when we crashed it into Saturn, that was on schedule, on plan, just to get some good atmospheric data on Saturn on its way down. But there's nothing there now. And so we're not really looking at Enceladus close up. However, the plan is hopefully to launch a mission to Europa. So this has been in the works for a long time, and it's 2020 now. So we're kind of, it's getting close to the time where people really hoped that this mission would launch, although I don't think that it's launching anytime soon, especially with the way things are now. However, there are some very serious things to think about when we want to launch some sort of probe to Europa. First of all, it can't be a Europa lander. Why not? Because while we have pictures of the surface of Europa from previous missions, we don't actually have a good enough understanding of what the surface of Europa looks like, right? So it's reckless to try and land something on it when we don't have a good landing site. We don't have enough information about it to determine what a good landing site would be. This mission is also not going to be a Europa orbiter. Why not? Well, Jupiter is one of those annoying planets that is so big and so energetic that it has its own radiation belt. And basically, what that means is that anything stuck in that radiation belt gets fried and blasted. And Europa is oftentimes in that the proximity of that radiation belt. So if we were to send a spacecraft with sensitive electronics to something that is sitting pretty inside of Jupiter's radiation belt, we'll just fry all the electronics and waste a lot of time and money and energy and blood, sweat, and tears. So what we're going to do instead, or what the community has chosen to do instead, is to develop a Jupiter orbiter that will fly by Europa several times from several different angles, and we'll be able to survey Europa in a lot of different wavelengths to understand exactly what's going on there. Because the end game, or a lot of folks would like us to eventually have a Europa lander and be able to drill into the subsurface ocean that we believe is there, that all evidence points to being there, right? So that we can understand it, and so that we can also probe for possible microbial life, which would be awesome. So all of these things are kind of in the works, but they're very exciting things. They're very cool things that are happening right in our own backyard, right? Which I think is neat. And so that is a little bit about Europa and Enchiladas, or Enceladus, two very cool cryomoons or ice moons in our own solar system. Okay. So I have something to talk about for next week, but after that, it's an open question. So if you have any questions or comments or things that you're curious about or just kind of want to know about from my perspective and expertise, please feel free to let me know. I would be happy to make you a video. And yeah, with that, just keep on keeping on, stay safe, and I'll see you next time.